Okay, in the last lecture, we calculated sunset diagram, but the calculation was not complete. Sunset diagram was first written in this form, and then we calculated Kp and P mu, K mu separately, and the results were given here. This is the result for Kp, and this is the result for K mu, P mu. And so we have to substitute these results in this equation and then calculate the final form of the sunset diagram. So let's do that. So sunset diagram, which is given by this one. Incoming momentum is P, and this is an amputated diagram. And collecting this results of Kp and K mu, P mu, and the prefactors, we write this expression. So this is what we get after collecting all the factors. Now we see that we have 1 over epsilon square pole, 1 over epsilon pole here. And these two terms are additive. So the maximum strength of the pole is 2. And so if we multiply with epsilon square, that will give you order 1 term, which we are neglecting. So we do not have to consider this expansion beyond this point. And mu to the power 2 epsilon can be expanded in powers of epsilon, as I have done before several times. So I can write 1 over 6 lambda square 1 plus epsilon log mu square plus order epsilon square 1 plus epsilon plus epsilon square. Then I take m square by 4 pi to the power 4 outside, and inside I take 3, this factor of 3 inside. That gives me 6 over epsilon square plus 3 over epsilon 1 plus 2 7. This can further be written as lambda square m square by 4 pi to the power 4 1 plus epsilon log mu square. I'm taking this factor of 1 over 6 inside here, And now one has to multiply these three factors here and keep the poles, pole terms only. And so if you take this combination 1, 1, and 1 over epsilon squared, that gives you the 1 over epsilon squared term. So that's a leading term. So minus lambda square m square over 4 pi to the power 4 times 1 over epsilon square plus, if you take then I have to calculate 1 over epsilon terms. So 1 over epsilon square can multiply 1 with this term, that will be 1 over epsilon square. So that's log mu square. And similarly, you can take 1 over epsilon square times epsilon times 1. That will give you a 1. 1 over epsilon times 1. Then you have to choose 1 over 2 epsilon. So that those are the two contributions coming from this factor. And then one, if we include this factor, then it has to multiply with 1 only. And so therefore, the coefficient of 1 over epsilon will be half times this, half 1 over 2 term, and 1 coming from the 1 over epsilon squared term will give you a factor of 3 by 2. Then psi 1, this psi 1 factor 2 cancels with this. Similarly, for this one, 2 cancels with this. This is 4 pi by log 4 pi by m square. And the 1 over epsilon square gives you a log mu square. So that combines with this term. These two terms combine, and it will give you log 4 pi mu square over m square. And this p square term, p square over 12 m square. Okay. Plus order 1. So that's the result for the sunset, final result for the sunset diagram. Let me now, so we have calculated so far all the desired diagrams. Let me now summarize the results. So I will summarize the results in the next portion here. So summary of results calculated found so far. I define lambda hat to be lambda divided by 16 pi square, and m hat square to be equal to m square over 4 pi mu square. So the first result is this tadpole, 2-point tadpole, that is given by half lambda hat m square times 2 over epsilon plus there's a order 1 term which is psi 2 minus log m hat square then order epsilon. Then number 2 double scoop that's given by minus 1 over 4 lambda hat square m square 4 by epsilon square plus 2 by epsilon times psi 1 plus psi 2 minus 2 log m hat square. Okay. That's order 1. Number 4 are the fish diagrams. There are 3 configurations 1, 2, 3, 4. One, 3, 2, 4. That will be given by, if you go to the we calculated one fish diagram, and you have to just change the moment, external moment accordingly, depending on which diagram out of these 3, which diagram you're considering. And if you do that, then convince yourself that you get this result. Where A is TU is given by sum over Z equals S comma T comma U 1 plus 4m square over Z to the power half log. Where S is P1 plus P2 whole square, T is P1 plus P3 whole square, and U is P1 plus P4 whole square. So these are the 3, these are usually called S, T, and U channels. Because the total incoming momentum in this case is P1 plus P2, in this case P1 plus P3, in this case P1 plus P4. As I said, we calculated the fish diagram where P1 plus P2 combination appears, and you have to replace that by the corresponding variable for the 3 different diagrams. And when we add them, you get this quantity here, and that is the final result after summing up the 3 diagrams. And you recall that after dimensional regularization, the coupling became lambda times mu to the power epsilon. And these diagrams are correction to the 4 vertex. So that's why it's a correction to the vertex factor. That's why lambda times mu to the power epsilon has been kept outside as a factor. And so the tree level diagram will produce only lambda times mu to the power epsilon. And that contribution is being corrected by this quantity in the bracket, which is why we did not expand mu to the power epsilon in powers of epsilon, because we want to compare that with the tree level. So this is the results.